Hello everyone. So welcome back to the good stuff that we've been doing. Here's a nice problem on number theory. So in this problem, we are asked to find the smallest k possible, such that 2 to the power of 69 plus k will be divisible by 127. And now here's a neat notation for this. Like if a divides b, we write it as a slash b. So this means that a divides b, for those who are not familiar with this notation. So in this case now, we're asked to find that k such that 127 will divide 2 to the power of 69 plus k. Let's assume that maybe k is like 27. Then the question is that is it possible that 127 will divide 2 to the power of 69 plus 27? Now, even if it divides, now the big question now is that the smallest k? Is that the smallest k possible such that this division would hold? Now let me take out this part and let's examine the problem critically. Now to do this, we have to just like ask ourselves, what does it even mean to divide? Like if 127 divides 2 to the power of 69 plus k, this means that 2 to the power of 69 plus k is congruent to 0 modulo what? 127. That is what it means. And this is congruence relation in number theory. So if 127 divides 269 plus k, then it means that 269 plus k, 2 to the power of 69, not 269, 2 to the power of 69 plus k would be congruent to 0 modulo 27. Now let us first of all, k is complex. So what I will do is we are going to study the powers of 2 in modulo 127. Let's say 2 to the k in modulo, let me use m, 2 to the m in modulo 127. That is what we are going to study now here. And if usually, because 127 is prime, you can confirm 127 is prime, it is easier for us to use Fermat's little theorem. Now Fermat's little theorem states that a to the m minus 1 is congruent to what? 1 modulo what? Modulo n. So if n is prime, so notice here that means 2 to the power of 126 is congruent to 1 modulo 127, but this is not so useful to us actually. Even though 2 to the power 126 is congruent to 1 modulo 7, we are dealing with 2 to the power of 69. But however, we can observe something that let's find the smallest k such that 2 to the power of p. Let me say let's use n. 2 to the power of n is congruent to 1 modulo 127. Now we already know that 126 is a possibility, but we want to find the smallest n such that 2 to the power of n is congruent to 1 modulo 27. Now 2 to the power of 7 is 2 to the power of 6 times 2, which is 64 times 2. That would be 64 multiplied by 2 would be 128. So obviously 128 is congruent to 1 modulo 127. Yeah, 128 will be congruent to 1 modulo 127. This means that 2 to the power of 7 is actually congruent to 1 modulo 127. So Fermat's little theorem guarantees us that 2 to the power of 126 is congruent to 1 modulo 127, but it is too large a number to be useful. But however, we have the smallest number possible is 7, so that 2 to the power of 7 is congruent to 1 modulo 127. So this means that we can actually try to like given this equation 2 to the power of 69 plus k. Let's assume that k does not exist, and let's break down the powers of 2 to the power of 69. Let's break it down to a manageable form. I will just take out the board now. We can continue later. Alright, so we already concluded that 2 to the power of 7 is congruent to 1 modulo 127. Now let's see, what does 2 to the power of 69 means in modulo 127? Well, let's break down 69, but put it in terms of 7. So that means that we are going to divide 69 by 7. So how many times does 9 go into 69? Well, that should be 9 times, because 9 times 7 should be 63, so that would be 63. Then this will be 6. That means this will be 9 times remainder 6. So this 2 to the power of 69 would be 2 to the power of 7 times 9 plus 6, which is same thing as 2 to the power of 7 multiplied by 9 times 2 to the power of 6, or we may write it as this is same thing as 2 to the power of 7 all to the power of 9 times 2 to the power of 6. Now this is congruent to, we already know that 2 to the power of 7 is congruent to 1 in modulo 127. So in modulo 127, this is congruent to 1 to the power of 9 times 2 to the power of 6. So this is congruent to 2 to the power of 6 in modulo what? In modulo 127. This means that this is congruent to 64 in modulo what? 127. This means that if we subtract, if we do 127 minus 64, that would give us this will be 3. Yeah, so this is 12 minus 6, that is 63. That means if we add 63 to 127, that is 2 to the power of 69 plus 63. This should be congruent to 0 modulo 127, because check it, 63 already is congruent to negative 64 in modulo 127. So 63, so this means that this is 2 to the power of 69 minus 120 minus 64, which is congruent to 0 modulo 127, because already 2 to the power of 69 is congruent to 64. That means 2 to the power of 69 minus 64 is congruent to 0 modulo 127. So for that is why we subtracted 64 from 127. So this means that k equals to 63 is the smallest k possible. Notice that we use the smallest k possible for which 2 to the power of 7 is congruent to 1 modulo 7. So modulo 127. So this 7 was the smallest possible n. That guarantees that k is the smallest possible. 63 is the smallest possible k for which this relation is true. So that means our answer is k equals to 63, and that settles everything. So thank you for watching, and please tune in to the channel by subscribing. I'll be posting more great videos on number theory as time goes on. Thank you for watching the channel and your time. Bye.